magnetic monopoles. They exist. They're real. They're right in front of you. You defined them improperly, so you can't see them. And I'm going to define them properly for you here now. The big shock that comes with that is that not only do magnetic monopoles exist, but they exist directly in your eyes sight. You can look up, and it's interesting that movie Don't Look Up just came out. So, but you can look up and see one half of the day or night, and that's because our moon is a magnetic monopole. How is our moon a magnetic monopole? Well, let's start with Gauss, who created the divergence times B, the magnetic field, equals 0. The reason he did this is because, quite literally, the big argument against magnetic monopoles right now is simply that magnetic field lines can't have a beginning or an end. If you think of a charge monopole as a star, and the light leaving the star as its field lines, then the field lines themselves start at the surface of the star and expand outward, and they keep expanding forever. And the problem with that is that magnetic field lines, as defined by Gauss, have no beginning or end. So if you try to build a magnetic monopole in the same way as you built a charge monopole, which is the star, then you can't. So this is one of the clear reasons why Gauss said you cannot have a magnetic monopole. Here's the thing though. If you look at a charge monopole, it is a force in, charge out system. And what that means is that this incredible gravitational field that it puts out brings a force against anything within it and pushes it inward in the system. And then the charge goes directly away. And if we try to build our magnetic monopole exactly opposite to that, then in Gauss's mind, what that meant is you had a core, and it was the very opposite. Magnetic field lines were going both ways out, away from the star, with no end. And of course, that can't happen. But what if instead we define magnetic monopoles as a reversal of the charge and force system, meaning that it's a charge in, force out system, not that the magnetic field lines begin with no end and radiate outward, but that charge starts outward and goes toward the core. And if that's the case, then the magnetic field lines around the force out system would simply be spherical. You would have round field lines with no beginning or end circling the core, which would be absorbing the energy because it's a charge in, force out system. So, if magnetic monopoles exist, and they do, and if it can be defined as force out, charge in, and the force out creating circular field lines around a core with charge going in, force going out, then magnetic monopoles can and do exist. There. Now, why do I think our moon is a magnetic monopole? Well, there's an enormous amount of data that proves it, and I'm going to hit the highlights here right now. There are plasma discharge marks on the moon. They look very close to craters created by asteroids and comets that hit the moon. But there are others that have not only the crater, but they have lines radiating from them. And they look exactly like plasma discharge marks created in the laboratory. And a scientist, and I can't remember his name and I feel bad about that, but a scientist came out with a paper and said, hey, these are plasma discharge marks. They're on the moon. we need to pay attention to this. And of course, he was ridiculed. What do you mean? Aliens came and shot the moon with their phasers, so there's plasma discharge marks. And, and that's a reasonable joke to make, when somebody says something like that. But the truth is, there are only 4 possible particles or types of particles in the universe. I mean, no matter how small you get or how large you get, there are 4. And I'll show you, it's in the book, and I'll explain it here. There are charged monopoles. There are charged dipoles. There are force, or what you call magnetic monopoles. And there are force, or magnetic dipoles. And that's it. Those are the 4. So if we start to name each of the particles in our system, and let's start with the solar system. Let's start with charged monopole. Everyone can know, and I think we'll agree, that the star is a charged monopole. And if you know that that's a charged monopole, and I'm telling you that the moons of the inner solar system are magnetic monopoles, then we have a charged monopole, we know what it looks like, and we have magnetic monopoles, and we know what they look like. And that only leaves our dipole structures. So there's charged dipole, and there's magnetic or force dipoles. And if you look at the inner planets, and for now let's just look at Venus, Earth, and Mars. And if you look at those, you quickly come to realize that though they appear to be magnetic dipoles, they aren't. And how would we know that? I mean, what proof of there is that? And the answer is Venus has no magnetic field. It looks like Earth. We call it our twin planet, our sister planet. And it has a much larger charge, but it has no magnetic field. So we can't be, these 3 inner planets that we're looking at, Venus, Earth, and Mars, can't be magnetic dipoles, even if they have magnetic fields like Earth and a small one like Mars. Because Venus, no doubt, is a charged dipole. And the thing is when I realized that, and I realized that the moon was a magnetic monopole, I realized that all Venus, Earth, and Mars are all charged dipoles. So where would the phaser blasts come from that hit the moon? And the answer is, if our planet is a charged dipole and the moon is a magnetic monopole, that a plasma discharge from the atmosphere of Earth would hit the moon and create the craters, the plasma discharge marked craters that were not created by asteroids and comets hitting the surface of the moon. So there you have an idea of what I'm talking about. Now, this creates more problems, if I'm right and the moon is a magnetic monopole, and it is, then we have an even bigger problem. You see, magnetic monopoles inside the charge monopole atmosphere of the sun, meaning our inner solar system, is a positively charged environment. And if the moon is a magnetic monopole, and it is, then what you end up with is probability that the plasma discharge marks are from the charged dipole discharging to the magnetic monopole. But under that model, then, the moon is a negatively charged object traveling through a positively charged field of the sun. And then you have to stop and think about that for a second, because that suddenly makes sense. Not only would the planet discharge to it, but you would immediately be able to apply Ampere's law. If what I'm saying is true, then our moon is a negatively charged particle traveling through a positive field, and that would create a magnetic field. How? Well, look at Ampere's law. If you consider that a charge in motion is considered a current defined by I in Ampere's equation, then our moon is that charge. Now, the idea, and let me explain it to you, is that if in Ampere's law, if a charge is traveling in a solenoid, right, which is a helical path, so if you have a wire in a helical shape and you send a charge down it, then it becomes a current, and a current traveling in a helical path or a solenoid creates a magnetic field. That's exactly what a solenoid really is. And so what I want you to do is apply Ampere's law to the moon. And the moon is the current defined by I. It's traveling, the Earth and the moon co-orbit each other around the star. It creates a solenoid. Plain and simple. If you were to just take Earth out of the picture and trace the path of the moon, it would be moving forward and in a circular path through space. So there's no wire, but there doesn't need to be. The wire is just to hold the current. And in space, that's not required. So technically, Earth is the wire, I guess, because it's what's holding the moon. But if you apply Ampere's law to the moon, you're going to find that it creates a magnetic field somewhere between the moon and the Earth. And there has been a huge amount of theory done on the Earth having a metal core, iron core that's spinning, and a spinning iron core would create a magnetic field. And everyone says that's where the Earth's magnetic field comes from, and they're wrong, plain and simple. If you apply Ampere's law to the moon, you're going to find that it creates a magnetic field because it's a solenoid, and that magnetic field is not centered on Earth. So the core of the magnetic field created by the moon in this solenoid is actually in space. And this tells us why there are places in space where your satellites just go dead. If this is true, then the moon has no gravity because it's a negatively charged particle. And you say that can't be true. We've landed on the moon. We've measured the gravity of the moon, and the gravity of the moon is 1.67 meters per second. And that's a problem, though, isn't it? The gravity of Earth is 9.8 meters per second. And technically, we're supposedly made of the same thing the moon's made of. The moon is a third our size, which means it should have a gravity somewhere at 3 something. But it doesn't. It's only 1.67. And this can be easily defined by me because it's not gravity. It's static charge holding you to the surface of the moon. And I know this is gonna, I must be crazy. That can't be right. So why do I believe that then? Well, A, because the moon would have to be negatively charged for it to create our magnetic field, to follow Ampere's law to create the solenoid, which creates the magnetic field of Earth. Then it wouldn't have gravity. Then it would only have static charge. So what other things could help us decide whether what I'm saying is even legitimate and a reason to even do the experiment, to apply Ampere's law? Well, when we landed on the moon, the regolith, the surface of the moon, jumped off the surface and landed on all over the suits of our astronaut. And this happened because we are, and our equipment, and the things that we have from Earth that we took there are positively charged, and the moon is negatively charged. Now, I know NASA came up with this thing where the solar winds traveling over the surface of the moon at this particular angle on this particular time causes a negative surface charge, No. The moon is a negatively charged object. That's why your electronics didn't work or begin to fail and not work when you landed on the moon. It's why the regolith jumps off the surface of the moon and sticks to the spaceship and our suits. And I mean, our suits started to break down within hours, because the negatively charged part just infiltrated the suits. And this is why. the moon is negatively charged. So how am I so sure? Well, because Bohr told us. See, in Bohr's model of the universe, there was quite literally what he called pair production, where a positive particle and a negative particle separate. And this pair production begins at 1.64, and our moon is at 1.67, which is to say not only is our moon a magnetic monopole as it orbits us, not only is it negatively charged and we're positively charged, plasma discharge is discharged from us to the moon, but Bohr called this pair production to begin at 1.64, and the moon is at 1.67. So the moon, being a third the size of Earth, should have a much higher gravitational force. And the reason it doesn't is because it's not gravity that's holding you there. It's quite literally static charge. So how can I prove this to you other than just giving you that? Well, let's look at the rest of the solar system and see how things play out. Well, if you look at the other planets on the inner solar system, you've got Venus, which has a very thick atmosphere, and it has relatively equivalent to Earth gravitational field. No magnetic field, though. And it has no moon. So if I'm saying that moons of the inner solar system are negatively charged, and using Ampere's law, they create a solenoid, which then creates the magnetic field, then Venus obviously wouldn't have a magnetic field. And Mars has one because it has two very, 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 very small moons. But those moons are creating, just like our moon, a very thin, very small magnetic field. So it fits so far. Problem is, when you look at our moon and you look at the other bodies in the inner solar system, you have to immediately notice that while Venus, Earth, and Mars look the same, Mercury does not. In fact, Mercury looks exactly like our moon, just larger. And that doesn't make a lot of sense. If what I'm saying is true about our moon, then it also must be true about Mercury. And that's another big shocker. I know, you know, Mercury is not a planet. Mercury is a magnetic monopole moon. Well, what would that mean? Well, if you look at the surface of Mercury, you find that it has the same plasma discharge marks and the same impact craters from asteroids and comets. And that would mean, quite literally, that at one point it must have circled a charged dipole to get the plasma discharge marks. And since Venus has no moon, you immediately must come to the conclusion that Mercury is Venus's moon, that it already reached pair production and separated, and that the sun's field pulled it in. In other words, Venus lost its moon to the star. And this is not just anecdotal evidence. The whole reason that Einstein came up with special relativity and general relativity was to originally simply define why Mercury's motion in our solar system could not be defined by Newton's laws. So we know, Einstein knew, everyone's known that Mercury itself doesn't follow Newton's laws. If Venus lost its moon, and it did, to the sun, and Mercury was Venus's moon, and it's now circling and orbiting the sun much closer, and it's going faster and faster, then we can say for sure that negatively charged particles travel toward the sun or inward in the solar system over time. And As they do, they get faster and faster. Mercury is speeding up and going faster and faster, but it's getting closer to the sun. That shouldn't happen. If Venus or Earth or Mars were to to accelerate, they would move away from the sun. Just like Earth has an escape velocity, and you must accelerate to that escape velocity to leave. The faster you go, the farther from the planet you get, because it's a gravitational field. And the sun's the same way. The faster you go, the farther you should get from the sun. And Mercury is actually moving toward the sun and increasing in speed. And this doesn't make sense, not by Newtonian mechanics. If our moon is creating a magnetic field around Earth, then we must assume that Mercury is doing the same thing to the star. And this creates another answer that we haven't been able to quantify yet. Not only the motion of Mercury around the sun, but why, even though the star, our sun, is a million times the size of Earth, its magnetic field is nowhere near a million times the size of Earth. If it was an internal magnetic field created by the size and the flow of particles, the sun's magnetic field should just dwarf Earth by like 1,000,000 to 1. And it doesn't. It's only a few times larger. So, if Mercury, and it is a magnetic monopole, and it is creating a solenoid around the star, then that is what's creating the sun's magnetic field as well. And this says a few things about our system. It means if we move our moon in or out from planet Earth, then we can adjust the magnetic field of Earth. I know that sounds strange, except in Bohr's model, and Bohr's model holds here, the moon is a massless object, which means Mercury is technically a massless object. And if you create a situation where you move Mercury in or out from the star, you're going to change the force of the magnetic field. And pretty soon the charged monopole of the star is going to discharge and evaporate Mercury. Since there are plasma discharge marks, then positive is discharging to negative. When Mercury gets closer, it's going to start pulling the magnetic fields that surround the sun out. And there's going to be more and more and more solar events. Solar flares, for instance. They're going to keep increasing, and they're going to keep increasing in strength, and they're going to keep increasing in frequency. So technically, Mercury is a lever that allows us to control the magnetic field of the sun. And our moon is a lever that allows us to control the magnetic field of Earth. Now, some of you intelligent people out there are already shaking your heads, screaming at your screen, no doubt, saying this guy's a freaking idiot. He has to be. How would you know that right off? Well, the tides of Earth, let's be honest. The tides of Earth are caused, supposedly, by the gravitational pull of the moon. So, what kind of moron would stand up and say that the moon has no gravitational field? Obviously, he's wrong. Shut off the video. Go away. Problem with that is that science has not fully identified polarity and the structure of molecules and atoms. See, they are also charged monopoles, charged dipoles, magnetic monopoles, and magnetic dipoles. And in the case of water, salt water, they are charged dipoles, just like our planet. Which means it's not gravity that's causing the water to well up in the center and to bulge out away from our planet. It's charge. Charged dipoles are attracted to the magnetic field of the moon. So when they say the moon causes the bulge of the water, the tides, they actually even tell you that if you map it out, the tides aren't trying to reach the moon. They're trying to reach a point between Earth and moon somewhere. And that's never been fully defined or explained, not properly. And the truth is, it's because it's not gravity. It's charge. The charge dipole of water is what is trying to align itself to the magnetic field created by the magnetic monopole circling us, creating a solenoid whose center is much closer to the Earth than the moon is. And the water, the charged dipole particles, are trying to get to that point, not to the moon. They're not being pulled to the moon, they're being pulled to the center of the magnetic field created by the solenoid that is the moon co-orbiting the star with our planet. So if this is true, and it is, then our moon is leaving us and will move inward and hit Venus. It will shatter, reform, and become Venus's moon, while depositing many of the molecules made and held within its structure on the surface of Venus. If this is happening to us right now, and if we see Venus has lost its moon and it's moved inward, then we have to look at Mars and say, why don't they have a large moon like Venus had in Mercury and like we have with our moon? It seems only logical that over hundreds of millions or billions of years that, Mars should also have one. Well, it did. You've heard the modern theory that a rogue planet called Theia hit us, and that's why we started spinning and how we got our moon to be created. And, well, if you take that story and you align it with the model that I'm giving you here, then Theia wasn't a planet either. Theia was a moon. In fact, Theia was Mars's moon. And it hit us, giving us all this water that we have on our surface, which sustained our charged dipole at a very mild level and protected us by creating our moon or enlarging it. And this creates a system now that we can watch. Mars had a moon. It lost it after pair production. It hit Earth, gave us our water. Parts of it reformed, causing our moon to enlarge. Our moon, over time, is now leaving us. And the moon that's leaving us will hit Venus. Venus had a moon. It reached pair production. It is now circling the star. Which means when you accelerate magnetic monopoles in the inner solar system, they don't move outward like charged dipoles in a magnetic or a gravitational field. They move inward. And this is opposite of what Newtonian mechanics say should happen, which is why probably no one's come up with this theory before. I'm not putting forward a model like string theory or M theory or, multiverse theory that can't be tested. I'm telling you, go use Ampere's law to measure, take my word, at least before you begin the experiment, that our moon is a magnetic monopole. It's a negatively charged particle. Measure that, take its path, define the solenoid, see the magnetic field, realize that Mercury is doing the same thing, and it's testable. I'm not just making this up. I have a theory of everything that is no longer a theory. It becomes self-evident.